Let's begin with an overview of data models. A data model is essentially the blueprint for how data is organized and structured within a database. They dictate how data is stored, accessed, and related to one another. On the right, you'll see visual icons that represent different data models. They include relational, hierarchical, network, and document data models. These models each have unique characteristics and are suited for different kinds of applications. Let's explore the relational data model. The relational data model organizes data into tables, which are also referred to as relations. Each table is structured with rows, also known as tuples, and columns, known as attributes. Every record in the table is uniquely identified by a primary key, ensuring that each entry is distinct. Relationships between tables are established using foreign keys, which create links between related data. The relational model adheres to the ACID properties, which stands for atomicity, consistency, isolation, and durability, ensuring data integrity and reliability. On the right, you'll see an example of two related tables, students and majors. The student_ID column in the students table is the primary key, uniquely identifying each student. The major_ID column is a foreign key, linking each student to their corresponding major in the majors table. Similarly, the major_ID in the majors table serves as the primary key for that table. Now, let's examine the hierarchical data model. This model structures data in a tree-like format with parent-child relationships. Each parent can have multiple children, but each child can only have one parent. Data is accessed by navigating from the root to the leaves. This model was prevalent in early IBM's Information Management System, or IMS, and is still used in modern Extensible Markup Language, or XML, and JavaScript Object Notation, or JSON. In the example displayed, you can see an organization structured hierarchically. The company is the root, with departments as its child. Engineering, marketing, and finance are children of departments, and teams, projects, and employees are further children, illustrating the tree-like structure. Let's delve into the network data model. This model employs a graph-like structure consisting of nodes and edges. Records can have multiple parent and child records, which supports many-to-many relationships. It is more flexible than the hierarchical model and was used in Conference on Data Systems Languages, or Codicil, and early network database management systems. As shown in the illustration, a social network can be modeled using the network data model. User, posts, friends, and groups are represented as nodes, with the relationships between them depicted as edges. This illustrates how users can be connected to multiple posts, friends, and groups. Let's discuss the document data model. Data in this model is stored in self-contained documents. It features a schema-free or schema-flexible design, allowing documents to contain nested structures. Complex joins are not needed, simplifying data retrieval. This model is popular in databases like MongoDB, CouchDB, and Firebase. The example displays a JSON document structure. You'll notice it contains fields such as ID, name, email, age, and address. These are all nested within the document, providing a flexible way to represent complex data. Let's consider the object-oriented data model. In this model, data is represented as objects with attributes, supporting inheritance and encapsulation. Objects have methods, also known as behaviors, and complex relationships are managed through references. This model is used in object-oriented databases. Here we can see a class inheritance example. Person is the base class with attributes like name, age, and address. Student and teacher inherit from person, adding their specific attributes and methods, like student ID and courses for student, and employee ID and department for teacher. Let's move on to the graph data model. This model represents data as nodes and edges. Nodes store entities such as people, places, or things, while edges represent the relationships between these entities. Properties can be attached to both nodes and edges. It's optimized for relationship queries and is utilized in databases like Neo4j, Amazon Neptune, and ArangoDB. The illustration shows a social network graph example. People such as Alice, Bob, and Charlie, places like New York and San Francisco, and events like a conference are represented as nodes. Edges indicate relationships, for example, that Alice is friends with Bob and that Bob lives in New York. Let's explore the column family data model. Here, data is stored in column families. Each row has a unique key, but columns can vary between rows. This model is optimized for high write throughput and is excellent for time series data. It's used in databases such as Cassandra, HBase, and ScyllaDB. The example shows user data in a column family model. User 1, User 2, and User 3 are row keys. Each user has column families such as profile and address. The columns within these families such as name, email, street, and city can vary from row to row. Let's dive into the key value data model. This is the simplest NoSQL data model. Data is stored as key value pairs, with keys serving as unique identifiers. Values can be strings, numbers, JavaScript object notation, or JSON or binary data. It facilitates extremely fast lookups by key and is used in databases like Redis, DynamoDB, and Ryak. Several examples of key value pairs are shown. Keys such as user:1001, session:xyz123, and counter:visits are associated with values that can be strings, objects, or numbers. This model has common use cases such as caching, session storage, user preferences, and real-time analytics. To choose the right data model, there are key considerations. These include the data structure and relationships, query patterns and access methods, scalability requirements, consistency versus availability needs, and development complexity. Common scenarios to consider are: if there are complex relationships, consider using graph. For structured data with a schema, use relational. If there is high write throughput, use column family. For simple lookups, use key value. For flexible schemas, use document. The data model comparison table provides an overview. Relational models provide excellent query flexibility, fair scalability, and poor schema flexibility. Document models provide good query flexibility and excellent scalability and schema flexibility. Key value models provide poor query flexibility and excellent scalability and schema flexibility. Graph models provide excellent query flexibility, fair scalability, and good schema flexibility. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.